Hey everyone, welcome to my channel. I hope you all are doing well. So, this is Jahanvi, your math tutor, and I'm back with another video on the topic composite functions. I have already uploaded 3 videos on this topic. So, if you have not watched those videos yet, I'm putting the link in the I button for the playlist. Please make sure you go to the playlist of functions and there you watch part 11, 12 and 13. Now in this part, we are going to do another type of question that you can expect from this topic. This question is going to be extremely interesting. So please make sure you do watch this video till the end. It would really help you to make your concepts much more clear on this topic. So let's get started. I'm going to write the question first of all. So let me read this question. So here we are given with two functions f of x that equals ax squared and g of x that equals 3x plus b. Also we are given with two equations that says g of f of 1 equals 5 and g of 2 equals 40. Then we have to find the values of the constants a and b, and we also need to find the value of g of f of -3. So this is the question. Now we are going to look at its solution stepwise. So let's start. So to find the answer to part A, we are going to use these two equations. Let me mark the first one as equation number 1 and the second one as equation number 2. So let us start working on the first equation here. So we will do g of f of 1 equals 5. Now in this composite function, it's clear that the input is f of 1. So we need to find its value first of all. So to find the value of f of 1, we'll go back to f of x, and here we will replace x with 1 everywhere because in f of 1 the input is 1. So here we will get f of 1 equals a times 1 squared. That will be equal to a times 1, that is equal to a. So that means in place of f of 1, I am going to put a. So we will get g of a equals 5. Now we need to find the value of this function. To do so, we need to go to the function g. And here we have to replace x with a everywhere in the function because in g of a, the input is a. So we will get g of a equals 3 times a plus b. So we are going to put this value in place of the function g of a. So that will give us 3a plus b equals 5. Now I'm going to mark this as equation number 3. Now we are going to use the second equation where we have g of 2 equals 40. Now here we need to find the value of g of 2. To do that, we will go back to the function g of x. I'm just going to erase what I have written before, otherwise it will be difficult to understand. So now to find the value of g of 2 where the input is 2, we will replace x with 2 everywhere. So that means we will get g of 2 equals 3 times 2 plus b. That is equal to 6 plus b. So in place of g of 2, I can write g of 6 plus b. That is equal to 40. Now, in the next step, I need to find what is g of 6 plus b. So again, I will go back to the function g of x. And here, first of all, you observe that in g of 6 plus b, the input is 6 plus b. So we are going to replace x with 6 plus b everywhere in the function. So then we will get g of 6 plus b equals 3 times 6 plus b plus b. Again, I have just replaced x with the desired input 6 plus b everywhere in the function. So then we will get g of 6 plus b equals this expression. I am going to put that here. So we will get 3 times 6 plus b plus b equals 40. Now we will simplify this. So 3 times 6 is 18. Then 3 times b is 3b. And then outside the parenthesis, we have one more b. So we will get 18 plus 3b plus b equals 14, which will become 18 plus 4b equals 14. Now to find the value of b, I will subtract 18 from both the sides. So then I will get 4b equals 14 minus 18, that is equal to negative 4. And when I will further solve this by dividing both sides by 4, we will get b equals negative 1. So we have found the value of one of the constants. So we know that b here is negative 1, and now we have to find the value of a. Now how can we do that? So if you focus on equation number 3, there we have 3a plus b equals 5. So if we will put the value of b here, then we will easily get the value of a. So let's do that. So in place of b, I am going to put negative 1 here. So then we will get 3a plus negative 1 equals 5. So we will have 3a minus 1 equals 5. Then we will add 1 to both the sides. So we will get 3a equals 6, and when we will divide both sides by 3, we will get a equals 2. So we have also found the value of a now. So a is equal to 2 and b is equal to negative 1. So we have solved part 1 here. Now let's do the second part. So here we need to find the value of the composite function g of f of negative 3. Now here you can clearly see that the input is f of negative 3. So we need to find the value of this first of all. So to do that, all we need to do here is replace x with negative 3 everywhere. So then we will get f of negative 3 equals a times negative 3 squared. That will be equal to a times 9, because negative 3 squared is 9. So we can write it as 9a. But we have already found what is the value of a, that is 2. So instead of writing it as 9a, we can write it as 9 times 2, that is equal to 18. So that means f of negative 3 equals 18. So I'm going to put that here, and then we will get the function g of 18. So now we have to find its value. So let's see how to do that. So let me erase this quickly. So to do that, we will go to the function g of x, and in g of 18, the required input is 80. That means in place of x, we are going to put 18 everywhere. So we will get g of 18 equals 3 times 18 plus b. That will be equal to 54 plus b. Now we already know what is the value of b, that is equal to negative 1. You can see here. So we are just going to put that here. So 54 plus of negative 1 equals 53. That means g of 18 equals 53. So that's the answer for part 2. So that's all for this video. If you were able to understand this question and my explanation to it, please make sure you do hit the like button, and if you have not subscribed to my channel yet, please do that first. Thank you so much.